wonder of galaxy, solar system. The night skies and astronomical bodies have been a source of wonder and speculation since the development of the earliest civilizations. The name and region of the ancient founder of the science of the stars are, however, both of them lost to us forever. But his discoveries survive and will endure, doubtless, as long as the planets shall continue to orbit the planetary system. 5,000 years on, our knowledge of the solar system and what lies beyond may be considerable. Yet, the sense of awe is hardly less than that was experienced by the earliest observers. To put it simply, starry nights have always attracted us since the childhood. You may also have thought of these stars and had numerous questions in your mind. Questions such as, how many stars are there in the sky? How did they come into existence? Can one reach the end of the sky? What is our position in the universe? Maybe many more such questions are still there in your mind. Now, you will learn how these stars and other astronomical bodies were formed. With that, you will eventually also learn of the origin and evolution of the Earth. A large number of hypotheses were put forth by different philosophers and scientists regarding the origin of the solar system. One of the earlier and popular arguments was by German philosopher Immanuel Kant. The mathematician Laplace revised it in 1796. It is known as nebular hypothesis. The hypothesis considered that the planets were formed out of a cloud of material associated with a youthful sun which was slowly rotating. Later, in 1900, Chamberlain and Moulton considered that a wandering star approached the sun. As a result, a cigar-shaped extension of material was separated from the solar surface. As the passing star moved away, the material separated from the solar surface continued to revolve around the sun, and it slowly condensed into planets. Sir James Jeans and later Sir Harold Jeffrey supported this argument. At a later date, the arguments considered of a companion to the sun to have been coexisting. These arguments are called binary theories. In 1950, Otto Schmidt in Russia and Karl Wiesackar in Germany somewhat revised the nebular hypothesis, though differing in details. They considered that the sun was surrounded by solar nebula containing mostly the hydrogen and helium, along with what may be termed as dust. The friction and collision of particles led to the formation of a disc-shaped cloud. The planets were formed through the process of accretion. However, scientists in later periods took up the problems of the origin of universe rather than that just of the Earth or the planets. The most popular argument regarding the origin of the universe is the Big Bang theory. It is also called expanding universe hypothesis. Edwin Hubble in 1920 provided evidence that the universe is expanding. As time passes, galaxies move further and further apart. You can experiment and find what the expanding universe means. Take a balloon and mark some points on it to represent the galaxies. Now, if you start inflating the balloon, the points marked on the balloon will appear to be moving away from each other as the balloon expands. Similarly, the distance between the galaxies is also found to be increasing, and thereby the universe is considered to be expanding. However, you will find that besides the increase in the distances between the points on the balloon, the points themselves are expanding. This is not in accordance with the fact. Scientists believe that though the space between the galaxies is increasing, observations do not support the expansion of galaxies. So, the balloon example is only partially correct. The Big Bang theory considers several stages in the development of the universe. In the beginning, all matter forming the universe existed in one place in the form of a tiny ball, singular atom with an unimaginably small volume, infinite temperature and infinite density. At the Big Bang, the tiny ball huge expansion. It is now generally accepted that the event of Big Bang took place 13.7 billion years before the present. The expansion continues even to the present day. As it grew, some energy was converted into matter. There was particularly rapid expansion within fractions of a second after the bang. Thereafter, the expansion has slowed down. Within the first 3 minutes from the Big Bang event, the first atom began to form. Within 3 lakh years from the Big Bang, the temperature dropped to 4,500 K and gave rise to atomic matter. The universe became transparent. The expansion of universe means increase in space between the galaxies. An alternative to this was Hoyle's concept of steady state. It considered the universe to be roughly the same at any point of time. However, with greater evidence becoming available about the expanding universe, the scientific community at present favors argument of expanding universe. The distribution of matter and energy was not even in the early universe. These initial density difference gave rise to differences in gravitational forces, and it caused the matter to get drawn together. These formed the basis for development of galaxies. A galaxy contains a large number of stars. Galaxies spread over vast distances that are measured in thousands of light years. The diameters of individual galaxies range from 80,000 to 1,50,000 light years. A galaxy starts to form by accumulation of hydrogen gas in the form of a very large cloud called nebula. Eventually, growing nebula developed localized clumps of gas. These clumps continue to grow into an even denser gaseous bodies, giving rise to the formation of stars. The formation of stars is believed to have taken place some 5 to 6 billion years ago. The following are considered to be the stages in the development of planets. The stars are localized lumps of gas within a nebula. The gravitational force within the lumps leads to the formation of a core to the gas cloud, and a huge rotating disk of gas and dust develops around the gas core. In the next stage, the gas cloud starts getting condensed and the matter around the core develops into small, rounded objects. These small, rounded objects, by the process of cohesion, develop into what is called planetesimals. Larger bodies start forming by collision, and gravitational attraction causes the material to stick together. In the final stage, these large number of small planetesimals accrete to form a fewer large bodies in the form of planets. Our solar system consists of 8 planets and their satellites. It also consists of several thousand minor rocky fragments called asteroids or planetoids, and a large number of comets. 2003 UB313 has also been recently sighted. The nebula from which our solar system is supposed to have been formed started its collapse and core formation sometime 5 to 5.6 billion years ago, and the planets were formed about 4.6 billion years ago. Our solar system consists of the Sun, the star, 8 planets, 63 moons, millions of smaller bodies like asteroids and comets, and a huge quantity of dust grains and gases. Out of the 8 planets, Mercury, Venus, Earth and Mars are called as the inner planets, as they lie between the Sun and the belt of asteroids. The other 4 planets, Jupiter, Saturn, Uranus and Neptune, are called the outer planets. Alternatively, the first 4 are called terrestrial, meaning Earth-like, as they are made up of rock and metals and have relatively high densities. The rest 4 are called Jovian or gas giant planets. Jovian means Jupiter-like. Most of them are much larger than the terrestrial planets and have thick atmospheres, mostly of helium and hydrogen. All the planets were formed in the same period, sometime about 4.6 billion years ago. The difference between terrestrial and Jovian planets can be attributed to the following conditions. The terrestrial planets were formed in the close vicinity of the parent star, where it was too warm for gases to condense to solid particles. Jovian planets were formed at quite a distant location. The solar wind was most intense nearer the Sun, so it blew off lots of gas and dust from the terrestrial planets. The solar winds were not all that intense to cause similar removal of gases from the Jovian planets. The terrestrial planets are smaller and their lower gravity could not hold the escaping gases. The Moon. The Moon is the only natural satellite of the Earth. Like the origin of the Earth, there have been attempts to explain how the Moon was formed. In 1838, Sir George Darwin suggested that initially the Earth and the Moon formed a single, rapidly rotating body. The whole mass became a dumbbell-shaped body and eventually it broke. It was also suggested that the material forming the Moon was separated from what we have at present, the depression occupied by the Pacific Ocean. However, the present scientists do not accept either of the explanations. It is now generally believed that the formation of Moon as a satellite of the Earth is an outcome of giant impact, or what is described as the Big Splat. A body of the size of 1 to 3 times that of Mars collided into the Earth sometime shortly after the Earth was formed. It blasted a large part of the Earth into space. This portion of blasted material then continued to orbit the Earth and eventually formed into the present Moon about 4.44 billion years ago. The planet Earth initially was a barren, rocky and hot object with a thin atmosphere of hydrogen and helium. This is far from the present-day picture of the Earth. Hence, there must have been some events or processes which may have caused this change from rocky, barren and hot Earth to a beautiful planet with ample amount of water and conducive atmosphere favoring the existence of life. The Earth has a layered structure, from the outermost end of the atmosphere to the center of the Earth. The material that exists is not uniform. The atmospheric matter has the least density. From the surface to deeper depths, the Earth's interior has different zones, and each of these contains materials with different characteristics. Man's curiosity has always driven him to search out the unknown and has led him to devise the means of exploring it. As man achieved the technological advances which permitted him to reach space, it was inconceivable that he should not explore it. As it was impossible in 1492 to forecast the benefits of the voyages of Columbus, so it is impossible now to foretell what man will gain from the exploration of space. It is, however, safe to predict that in the long run, the most important and valuable return from space exploration will be the vast addition to humankind's store of knowledge about the universe in which he lives. Man will establish permanent stations in and beyond space, laboratories, observatories, experimental testing platforms, and way stations. He has visited the moon, but will visit Venus and Mars. He will send probes to more distant planets and perhaps the stars. He may discover that life exists in space. He may communicate with other beings in space. Regardless of what form his exploration takes or what other results he may achieve, man's greatest benefits will still be the knowledge he brings back for the benefit of mankind. Man's achievements until this very moment have been tremendous, but they pale as feeble ventures when we contemplate what possibilities exist in terms of future space explorations. Only in the light of what man has already done could he possibly look ahead with the almost certain knowledge that many of the projects he now looks forward to will be realized. Man dreams of visiting the other planets in our solar system. He casts an eye at the other stars of our galaxy, the Milky Way.